Okay, let's unpack this. We are about to dive deep into what is arguably the most electrifying and, well, consequential race in technology today. We're talking about the sprint to artificial general intelligence, or AGI.
Mm-hmm. Definitely the big one.
For years, the prevailing wisdom, the kind whispered in Silicon Valley boardrooms and splashed across tech headlines, has been pretty clear.
Yeah, the big players have it locked down.
Exactly. The vast, well-funded AI giants are seen as the undisputed frontrunners. Why? Well, simply because they possess more of everything, more GPUs, more data, more compute power, and frankly, just way more money to throw at the problem.
The resource advantage is just staggering, really.
Their path to AGI seems almost inevitable, doesn't it? Like a brute force march fueled by these immense resources.
That's certainly the dominant narrative. More is better, bigger is faster.
But what if that conventional wisdom is profoundly incomplete? What if there's an entirely different path? A truly groundbreaking strategy, maybe?
Interesting angle.
One that could allow a vastly different kind of contender. One operating with just a fraction of those resources to not just compete, but maybe even potentially pull ahead.
That would certainly shake things up.
That's precisely the intriguing premise we're exploring in this deep dive. Our analysis is centered around a truly fascinating article titled Open Source AGI, a blueprint for collective intelligence.
Right, I've seen that one. It proposes a pretty radical departure.
Absolutely. Our mission today is to meticulously explore this theoretical framework and a practical step-by-step process for how the open source community could potentially beat these AI giants to AGI. And trust me, it's going to involve some surprising insights and a unique approach to problem solving, one that doesn't rely on simply having the biggest war chest. It relies on something, well, far more agile and intelligent.
What's truly fascinating here, as you've just alluded to, is how the conversation around AGI often assumes this singular, inevitable path. One paved by immense corporate resources, and that more is better philosophy.
Yeah, that's the default assumption.
But this particular source, it proposes a radical and, I think, really compelling shift in perspective. It suggests that ingenuity, collaboration, and critically algorithmic efficiency, rather than sheer computational brute force, could actually be the winning ticket.
Ingenuity over raw power.
Exactly.
Yeah.
It really sets a compelling stage for a discussion about how the open source community, despite the, staggering resource disparities when compared to major corporations, could still emerge as not just a participant, but potentially the dark horse, in this absolutely critical race for general intelligence.
A dark horse with a very different strategy.
We're not just talking about incremental improvements here. We're talking about a fundamentally different way to approach the problem. A whole new game plan.
So let's start by laying the foundation. We need to acknowledge the sheer, almost intimidating scale of the challenge we're talking about when we discuss AGI.
It's monumental.
The article immediately throws down a gauntlet with a rather humbling statement. It asserts that, and I quote, "We humans aren't intelligent enough to get to AGI or solve other daunting problems like memory and hallucinations without the assistance of AIs."
Wow, that's quite a claim right off the bat.
It is. Now take a moment to really consider that. That's a pretty humbling thought, isn't it?
Definitely makes you pause.
Have you ever grappled with a problem so complex, so multifaceted, that it felt like you needed, a supercomputer in your brain just to even begin to think about it, just to hold all the variables in your mind?
Absolutely. Many times. Research often feels like that.
Right. Well, this challenge, the very creation of AGIs, is on that kind of scale, but for humanity as a collective. It's basically an acknowledgement that our own cognitive limits are perhaps the bottleneck here.
Absolutely. And the implications of that statement are profound, and I agree, incredibly humbling. It's not just about raw computational power or the ability to process data at incredible speeds, though that's part of it.
There's more to it.
Much more. AGI involves a level of understanding, context, causal reasoning, and potentially self-correction that goes far beyond what even the most brilliant individual human minds, or even large groups of human minds, coordinating in traditional ways, can currently grasp or effectively coordinate on their own.
So it's not just about processing, it's about genuine understanding and adaptability.
Precisely. Consider specific challenges like achieving truly persistent memory across diverse tasks. An AI remembering and applying past learning flawlessly across entirely new domains without forgetting or conflating details, that's incredibly hard.
Yeah, we see models forget things all the time.
Or think about truly eliminating hallucinations, where an AI confidently just invents facts or generates outputs that are completely nonsensical but sound plausible.
The confident falsehoods, a major issue.
These aren't just minor bugs you can easily patch with more data. They represent fundamental hurdles, deep conceptual chasms that really highlight the inherent limitations of our current human-centric approaches to building intelligence.
So the complexity itself points to needing help.
It really does. If even brilliant human minds are insufficient to conceptualize and build this next level of intelligence independently, it strongly suggests that the very nature of AGI itself might be a problem that inherently requires an intelligent collaborator and AI partner to solve.
So AI helping build AGI.
This truly sets the stage for any successful approach to AGI, whether it originates from a corporate giant or an open-source collective, to necessarily involve sophisticated AI assistance in its own development. We're talking about building a ladder to the next level of intelligence with the help of an intelligence already partway up that ladder. It's recursive in a way.
That's a fascinating way to put it. Okay, so with that immense challenge established, let's look at the current landscape. Right now, the dominant strategy from those corporate behemoths, the AI giants, as the article aptly labels them, is what's unequivocally described as a brute force approach. The source tells us they'll be using this approach because they have the GPUs and can afford the compute and other costs. It sounds very straightforward, almost like an industrial approach to innovation.
Precisely. And in this context, brute force isn't really meant as a pejorative term, I think, as much as it is a descriptive one for a specific resource-intensive strategy.
Just describing what they're doing.
Exactly. It essentially means throwing an immense and ever-increasing amount of computational power at the problem, primarily through vast arrays of specialized graphics processing units, the GPUs that have become, the new gold standard in AI development.
The engines of modern AI.
Right. This is a strategy that directly leverages their overwhelming economic and infrastructural advantages. They can afford to build these colossal data centers, fill them with tens, maybe hundreds of thousands of these powerful chips, train models on unimaginable quantities of proprietary data, and run experiments that would financially cripple or simply be physically impossible for any smaller organization or individual.
The scale is just hard to comprehend.
It really is. Imagine, if you will, trying to build the fastest car in the world. The brute force approach would be to simply keep putting a bigger and bigger engine in it without fundamentally rethinking aerodynamics or the materials used in its construction or even the basic principles of combustion.
Just more horsepower.
Just more horsepower. And this approach works, up to a point, certainly. You will undoubtedly get a faster car with enough horsepower. But it can easily lead to diminishing returns, massive inefficiencies in terms of energy consumption and cost.
Right. The energy cost alone is huge.
Huge. And crucially, it might completely miss fundamental innovations that come from a more elegant, efficient, and intelligent design, maybe breakthroughs in material science, or a radical new engine architecture that sips fuel but delivers incredible power.
A smarter design, not just bigger.
Exactly. So while powerful and capable of producing impressive results, this brute force methodology inherently suggests that the solution to AGI lies predominantly in sheer scale and resource expenditure rather than, say, conceptual breakthroughs or algorithmic finesse. It's about overwhelming the problem with power rather than fundamentally outsmarting it.
And this, of course, creates the central, compelling conflict of our deep dive. Because the open source community, with its inherent resource limitations, well, they can't play that game. So they're proposing a completely different counter strategy.
Which they have to.
One centered not on raw power, but around intelligent algorithms. The article posits that if the open source community develops ANDSIs that are more powerful specifically in the problem-solving domain, these ANDSIs can then tackle the harder problems of getting to AGI through more intelligent algorithms rather than more GPUs and compute.
ANDSIs, Advanced Novel Distributed Search Intelligences, that's the term they use.
Right. Here's where it truly becomes intriguing, I think. It's a classic David versus Goliath story unfolding. But David's weapon isn't just a slingshot, it's a fundamentally different and arguably maybe even a superior way of thinking about the problem.
It absolutely is, and this is where the proposed path diverges so dramatically from the established narrative.
Yeah.
This is a paradigm shift being advocated. The focus moves away from simply acquiring and utilizing more resources to a far more sophisticated and smarter utilization of the resources you do have.
Doing more with less.
Precisely. When the source talks about developing these ANDSIs that are more powerful specifically in the problem-solving domain, It implies a highly targeted and specialized focus. We're not necessarily talking about building another general-purpose chatbot here, not initially anyway.
Something more focused.
Exactly. We're talking about a new class of highly specialized AI agents designed from the ground up to be super efficient problem solvers. Think of them as dedicated, intelligent agents singularly focused on tasks like rapid pattern recognition in complex data, highly efficient logical deduction, or generating optimized code tasks that are core to the grand challenge of AGI itself.
So agents built for reasoning, not just talking.
Right. It's not about them possessing a vast repository of general knowledge like a large language model. It's about them being fundamentally better at thinking, reasoning, and crucially, solving novel problems with exceptional efficiency. They're lean, mean problem-solving machines.
That distinction seems critical.
It is. This distinction between raw computational power and algorithmic efficiency is absolutely critical because it represents a profound difference in strategy. Could this truly represent a more sustainable and potentially more innovative path to AGI? What are the inherent advantages of focusing on intelligence efficiency rather than sheer scale?
Right. What does efficiency buy you?
It suggests that the true bottleneck to AGI might not actually be a lack of hardware, but rather a lack of sufficiently intelligent algorithms themselves. And this open source approach seeks to cultivate those algorithms. It's like building an intellectual infrastructure designed for maximum cognitive leverage, allowing them, theoretically, to outmaneuver opponents who are simply trying to outspend them. It's about being smarter, not just bigger.
What makes this entire blueprint even more fascinating, adding this really interesting meta layer to our discussion, is the very process by which it was developed. The author reveals that they brainstormed this entire strategy, this intricate, detailed plan for achieving AGI with AI assistance with an AI.
Ah, yes, the Grok 4 collaboration.
Exactly, specifically with a highly advanced model known as Grok 4. So the very concept we're analyzing right now about AI helping us build AGI was itself a product of human-AI collaboration. How meta is that?
It's incredibly meta, and this detail is not just a fascinating anecdote. I think it raises a truly important question about the future of problem solving itself.
How so?
Well, the blueprint for achieving AGI with AI assistance was, in this recursive and profoundly interesting way, itself developed with AI assistance. It's a compelling feedback loop, isn't it?
It really is.
This meta point has profound implications for how we, as humans, will tackle increasingly complex, maybe even existential problems moving forward. It suggests that the path to higher intelligence might not be a solitary human endeavor, or even a purely human collaborative one anymore,
But a partnership.
but an increasingly collaborative journey with the very intelligence we seek to create. Are we entering an era where our most profound breakthroughs will almost inherently be a co-creation between human ingenuity and intelligent systems? It really blurs the lines of authorship and potentially accelerates discovery in ways we can only begin to imagine. It fundamentally challenges our traditional notions of innovation, I think.
It really does. So given the critical nature of this task, devising a strategy to achieve AGI, why Grok 4, why was this specific AI chosen as the strategic partner for such a crucial brainstorming session over other powerful models that exist?
Good question.
The article provides us with two very compelling reasons. First, it states, it is currently our most powerful model in terms of the fluid intelligence required for problem solving. Fluid intelligence. Okay, what does that mean in this context?
Fluid intelligence as a concept is absolutely central here. In human psychology, it's defined as the capacity to reason and solve novel problems, independently of acquired knowledge or past experience.
Solving new stuff, basically.
Exactly. It's about seeing abstract relationships, understanding complex patterns, and solving problems that aren't just based on previous memorized experience. For an AI model, this translates to its ability to engage in sophisticated logical reasoning, to identify emergent patterns in unprecedented situations, and critically, to generate genuinely creative and novel solutions to entirely new challenges.
So not just pattern matching, but real reasoning.
Right. For brainstorming a groundbreaking AGI strategy, a problem for which no established playbook exists, this capability is absolutely critical. You don't just want an AI that regurgitates existing information or offers slight variations on known solutions.
You need something genuinely new.
You need one that could explore entirely new conceptual spaces, connect disparate ideas in innovative ways, and essentially think outside the conventional box. Grok 4's perceived strength in this area apparently made it an ideal partner for devising a truly novel and potentially disruptive approach, one that looks beyond the conventional wisdom of just scaling up. It's about being truly generative in its problem solving, not just iterative or
Yeah.
derivative.
Okay, that makes sense. Fluid intelligence is key for novelty. But the second reason offered is even more intriguing, I think. It highlights something you might almost call the personality or the disposition of an AI model, a factor we rarely consider.
The AI's attitude.
Sort of. The source says, while ChatGPT-5 is also good for this kind of work, it tends to be pessimistic, overly focusing on the problems involved, whereas Grok 4 tends to be much more optimistic and encouraging and focuses more on the possible solutions.
That is fascinating.
Isn't it? This is a fascinating distinction. Think about your own brainstorming sessions. How much does the mindset, the inherent disposition of the people involved influence the outcome? Are they problem-focused or solution-focused?
Oh, hugely. A pessimistic group can kill ideas before they even get explored.
Right. And even AIs, it seems, have different personalities or maybe default stances when it comes to tackling tough problems.
This is a truly remarkable and incredibly insightful observation into how the very disposition, or what you might perhaps call the attitude, of an AI model can profoundly influence its utility in different contexts.
So the AI's vibe matters.
It seems so. An optimistic, solution-oriented approach, like Grok 4's is described here, can be far more conducive to true innovation and strategy development, especially when you're facing something as monumentally daunting as the AGI challenge.
Because you need that can-do spirit almost.
Exactly. A model that constantly highlights obstacles, meticulously pointing out every potential pitfall and limitation, while perhaps very accurate in its assessment of risks, might inadvertently stifle the creative, bold thinking needed to actually find a viable path forward. It's not that pessimism or critical analysis is inherently bad, of course.
No, you need realism too.
You absolutely need realism.
Huh.
But for generating a blueprint for what is possible, for charting a course through uncharted territory, an optimistic lens, a focus on solutions, becomes a distinct advantage. It keeps the momentum going.
It's like choosing a consultant, maybe.
That's a great analogy. Compare it to choosing a human business consultant. One might be brilliant at identifying every single potential pitfall and risk, offering a comprehensive, perhaps slightly demotivating, assessment. Another, equally brilliant, focuses on finding a viable path through those obstacles, identifying opportunities where others see only barriers, and framing challenges as solvable problems.
You'd probably want the second one for brainstorming a bold new venture.
Often, yes. The latter is often far more effective for generating a constructive roadmap and maintaining momentum, especially in a highly ambiguous and challenging domain like AGI. This suggests that the attitude or framing disposition of our AI partners will become an increasingly important selection criterion, not just their raw intellectual horsepower. It highlights a much more nuanced understanding of human-AI collaboration, where even the sort of emotional tenor or bias of the interaction can dictate creative output.
Fascinating. Okay, so armed with this unique AI partner, Grok 4, which is strong in fluid intelligence and has an optimistic bent, the author developed a core strategy for the open source community, a strategy that feels incredibly agile and, frankly, profoundly smart. Grok 4 suggests leveraging a hybrid approach that combines lightweight prototyping with automated experimentation and collaborative infrastructure. So what does this all truly mean in practical terms? For the open source community trying to, punch above its weight against these resource-rich AI giants?
Right. Let's get down to brass tacks. This is precisely where the open source advantage, when it's intelligently leveraged, really starts to shine. Let's break down each crucial component of Grok 4's suggestion, because together they form a really powerful synergistic whole. It's designed specifically to outmaneuver that brute force approach.
Okay, component 1. Lightweight prototyping.
Absolutely crucial. In the corporate AI world, launching a new model or even just a significant new feature can involve months of planning, immense compute allocation, layers of bureaucratic approval. It's slow and expensive.
Yeah, turning the Titanic.
Pretty much. For open source, lightweight prototyping means being able to quickly test out new ideas, iterate on concepts rapidly, and crucially, throw away designs that don't work without breaking the bank. All with minimal resource expenditure. It dramatically lowers the cost of failure.
Failure becomes learning, not disaster.
Exactly. It transforms failure into a cheap learning opportunity rather than a prohibitive setback, thereby allowing for a far greater volume of experimentation. This agility, this speed of iteration, is a direct counter to the slow, heavy movements of massive organizations.
Okay, agile prototyping. What's next?
Next is automated experimentation. This takes things a critical step further. Instead of humans needing to manually run countless trials, painstakingly configure experiments, analyze results, which is incredibly time-consuming.
And prone to bias sometimes.
And prone to bias, yes. The system itself, using frameworks like the Sakana one mentioned later, can generate hypotheses, rigorously test them against vast, carefully curated data sets, and analyze the results far more efficiently and objectively than any human team possibly could.
So the AI helps run the experiments.
It automates large parts of the scientific process. This dramatically accelerates the pace of discovery and allows for an exploration of possibilities, of different algorithmic combinations or tuning parameters that would be simply impossible with human intervention alone. It's like having a tireless, unbiased scientist working 204/7 at machine speed.
Wow. Okay, prototyping, automated experiments. What's the third leg?
The third leg is collaborative infrastructure. This is perhaps the most characteristic strength of the open source world, but here it's applied with a very specific strategic purpose towards AGI.
Leveraging the community.
Precisely. It's about intelligently pooling knowledge, dividing labor effectively among a globally distributed community of brilliant minds, and leveraging diverse skills and perspectives that no single corporation could easily replicate. When you combine these three elements, rapid, cheap iteration, tireless automated testing, and collective intelligence harnessed through collaborative infrastructure,
You get something powerful.
you don't just create an engine for innovation. You create an engine for accelerated, resource-efficient innovation. It sounds very much like an agile development methodology, but scaled up for fundamental scientific discovery. It allows David to potentially outmaneuver Goliath by being quicker, smarter, and far more adaptive. Every unit of compute, every hour of human effort is leveraged for maximum strategic impact.
So the ultimate goal of all this, as the article emphasizes, is to create a strategy that draws on existing open source tools to create a feedback loop that's fast, cost-effective, and scalable, allowing the community to iterate toward AGI-level capabilities without relying on massive compute resources. It's about building a self-improving intellectual ecosystem, not just individual models.
Exactly right. That statement perfectly distills the core strategic advantage into three critical outcomes. These outcomes directly address and potentially nullify the resource limitations faced by the open source community when compared to the AI giants.
Okay, walk us through those three outcomes.
First, speed. Speed is paramount for iterating on complex problems like AGI, where breakthroughs can happen quickly, and the pace of development is just accelerating exponentially. A rapid feedback loop ensures that lessons learned, both successes and failures, are immediately integrated back into the development process, preventing wasted effort and allowing the community to rapidly capitalize on emergent insights.
Faster learning cycles.
Much faster. Second, cost effectiveness. This means the community can sustain ambitious, long-term development towards AGI without needing multi-billion-dollar budgets. This is achieved through clever algorithmic design, focusing on efficiency, sharing resources, and minimizing the computational overhead of experiments. It directly undermines the AI giants' primary advantage, their massive compute resources.
Making smarts count more than dollars.
Precisely. And third, scalability. This is crucial. It means that as more contributors join the effort, as more ideas are proposed and tested, the system doesn't get bogged down or more complex to manage. Ideally, it gets more powerful and efficient. The collective intelligence compounds, rather than creating bottlenecks.
The network effect for innovation.
Exactly. This rapid feedback loop is critical here, as it allows for continuous improvement and adaptation in what is still a highly unpredictable domain. Imagine again that small, nimble, highly coordinated racing team. They can quickly build, test, and refine modifications to their car after every single lap, constantly optimizing for performance based on real-time data.
While the big team is still in meetings.
Well, maybe not that bad, but compared to a huge corporate team that might take months to move a new design through layers of bureaucracy, extensive simulations, and prolonged physical testing before it even sees a real track. The former, even with fewer initial resources, can often out-innovate, react faster to new track conditions or competitor moves, and ultimately find a winning formula more quickly.
Agility wins.
Agility and rapid learning. So, if we connect this to the bigger picture, this blueprint described in the article is really about innovation born directly from constraint. It's a powerful testament to what happens when you're forced to optimize for intelligence, for collaboration, and for adaptive learning, rather than simply throwing endless resources at a problem. It's a fundamental reimagining of the innovation pipeline itself.
This sounds incredibly promising, a truly sophisticated counter-strategy, but the real question, of course, is how do you actually do it? This isn't just high-level theory, right?
No, the article gets specific.
Grok 4, in its collaborative role, has apparently laid out a clear, actionable six-step blueprint for this hybrid approach. Let's walk through it meticulously, step by step. Starting with step 1. Select accessible base models. The article says choose from the latest open source options available on platforms like Hugging Face, such as Llama 3.18b, DeepSeek V2, or Qwen 3.7b. This isn't just about picking any models. It feels like a very strategic choice right from the outset.
It absolutely is. This first step is foundational for the entire strategy, and that emphasis on accessible models is really key. It immediately lowers the barrier to entry for countless developers worldwide.
Democratizing access.
Exactly. It ensures that participation isn't restricted only to those fortunate enough to have access to immense corporate compute clusters or proprietary datasets. As many of your listeners will know, Hugging Face is highlighted because it's essentially become the central marketplace, the vibrant collaboration hub for the global open-source AI community. It makes it incredibly easy to discover, share, and utilize these powerful models.
It's the town square for open source AI.
A very apt description. Now, models like Llama 3.18b, DeepSeek V2, or Qwen 3.7b, these aren't just good general-purpose models. Their accessibility here is their superpower in this context. They are, as the article puts it, ideal starting points for generating quick, inexpensive prototypes.
Connecting back to that lightweight prototyping idea.
Precisely. This directly ties back to the concept of lightweight prototyping we discussed earlier. It allows rapid experimentation without the prohibitive computational overhead, the time, and the cost involved in training massive foundational models from scratch. It means the open source community can jump straight into iterative innovation, building on existing, robust foundations that others have already laid down.
Standing on the shoulders of giants, but open source giants.
In a way, yes. And crucially, the focus here isn't on using these models for general knowledge tasks, like writing poetry or summarizing articles. The specific recommendation is to use them for tasks like coding agents that rapidly identify patterns in logic puzzles, math challenges, or algorithmic problems.
So focused on problem-solving skills again.
Exactly. This directly links back to the overarching goal we discussed, developing those specialized ANDSIs that are more powerful specifically in the problem-solving domain. The community isn't trying, at least initially, to build a completely new general-purpose chatbot from scratch, which would be a colossal and resource-intensive undertaking.
They're building specialists.
They are laser-focused on honing specific reasoning and analytical capabilities that lie at the very heart of general intelligence. Think of it like a chef choosing quality, readily available ingredients from a well-stocked market to begin a new, complex recipe. They're not trying to cultivate rare, exotic produce on their own first.
They're starting with good, proven components.
Good, proven components, ready to be refined and specialized for the specific dish they want to create. This allows for distributed effort and parallel experimentation across the community, which are hallmarks of open source strength. Everyone can grab a base model and start tinkering.
Okay, so we've carefully selected these agile, accessible base models, our initial tools in this race against the giants. But simply having the tools isn't enough, right? We need to hone them, specialize them for the job.
Correct. That leads directly into the next step.
Which brings us to what I imagine is a truly crucial step. Fine-tune the base models. The source tells us to apply techniques like LoRa for domain-specific adjustments, such as boosting performance in scientific reasoning or code optimization, and then incorporate quantization and pruning to ensure the models remain lightweight and efficient, enabling them to run on modest hardware without high costs. So, is this fine-tuning just a minor optimization, or is it really a strategic imperative for the open source community? Is this how they leverage intelligence per watt, fundamentally shifting the resource equation?
Oh, it's absolutely the latter, a strategic imperative. It's a foundational pillar of how this whole approach is meant to compete. This step is all about taking those accessible base models and making them hyper-efficient and highly specialized for the specific problem-solving task at hand. It's about transforming them from generalists into high-performance specialists.
And LoRa is key here. What is LoRa exactly?
LoRa, or low-rank adaptation, is a real game changer here, and it's a strategically brilliant move for the open source context. Think about the AI giants. When they want to significantly adapt a model, they often need to retrain large parts of it, or even the entire thing from scratch. That's a process costing potentially millions of dollars, consuming vast amounts of energy, and taking weeks or months.
The brute force retraining.
Right. LoRa, however, allows the open source community to make targeted, domain-specific adjustments with remarkable efficiency. You can take a general-purpose model, say one of those llama variants we mentioned, and surgically fine-tune it to excel in a specific niche, like scientific reasoning or code optimization, without retraining or altering its massive core pre-trained weights. You're essentially adding small, trainable adapter layers.
So it's like adding a specialized module instead of rebuilding the whole engine.
That's a perfect analogy. It's incredibly resource efficient. It allows for rapid specialization without the massive overhead. It's like that nimble racing team taking a high-performance production car and, through incredibly clever targeted modifications, maybe optimizing its aerodynamics for a specific track, shedding every ounce of unnecessary weight, fine-tuning its suspension, just so transforming it into a track-beating specialist.
They're not building a new engine from scratch.
Exactly. They're maximizing the intelligence per watt or performance per resource of their existing accessible base, allowing them to potentially outmaneuver the bigger, heavier competitors through smart specialization.
Okay, Laura, for specialization, what about quantization and pruning? They sound like making models smaller.
They are, and these are not mere technical tweaks either. They are critical techniques for making models lightweight and efficient, which is central to the entire strategy. Quantization basically reduces the precision of the numerical representations within the model. Think of it like using fewer decimal places to store numbers.
Rounding things off a bit.
Sort of, but in a very optimized way. It makes the model significantly smaller on disk and faster to run because the calculations are simpler, often without a huge drop in performance if done carefully. Pruning, on the other hand, involves strategically removing less important connections or parameters from the neural network, like trimming dead or unnecessary branches from a tree to make it healthier and more focused.
Getting rid of the fluff.
Essentially, yes. Both techniques significantly reduce the model's size and its computational demands, and this directly enables them to run on modest hardware without high costs. This is absolutely fundamental for democratizing powerful AI development.
So developers don't need a supercomputer in their basement.
Precisely. It means developers don't need access to massive server farms to contribute meaningfully. They can work effectively on powerful laptops or readily available affordable cloud computing instances. This whole step is about getting the absolute maximum intelligence per unit of compute, per dollar spent, per watt consumed. It directly combats the brute force advantage of the AI giants by making every single computational cycle count. This efficiency isn't just a minor advantage, it's a foundational pillar of how they intend to compete and potentially win.
Okay, so these fine-tuned, lightweight, and now highly specialized models are ready. They're lean, mean, reasoning machines. But they need to be put to work within a larger system, right? A system that helps them improve collectively.
Exactly. They need an environment for experimentation and learning.
That brings us to step 3, integrate with advanced open source frameworks. The blueprint suggests we feed the outputs from your fine-tuned base models, such as rough ideas, strategies, or partial solutions, into Sakana's AI Scientist, now updated to V2 as of 2025. This sounds like something out of science fiction and AI Scientist.
It does sound futuristic, but it's very much within the realm of current technological advancement, or at least near future development described here. And this is where the magic of that automated experimentation idea we discussed truly comes alive.
Okay, tell me more about Sakana's AI Scientist.
Sakana's AI Scientist V2, as described, isn't just a passive tool or library. It's envisioned as an active, intelligent system designed to act as a kind of meta-researcher, coordinating the efforts of the specialized models. The inputs it receives, those rough ideas, strategies, or partial solutions, are the intellectual contributions, the initial sparks of hypotheses generated by our smaller, fine-tuned base models.
So the small models generate ideas.
Exactly. They effectively form the hypotheses generation, part of a continuous AI-driven scientific process. Then, within this Sakana framework, the system automates key processes, generating hypotheses based on those inputs, running experiments on curated datasets, and outputting refined models or detailed reports.
So it takes the ideas and tests them automatically.
Yes, this is the core of the automated scientific research assistant at work. It systematically tests the ideas generated by the smaller models with a rigor and speed that humans couldn't match. And the emphasis on curated datasets is crucial here. They're not just throwing any data at it.
What kind of data?
The article mentions examples like distilled reasoning traces from larger models, meaning the compressed, most valuable step-by-step thinking processes extracted from massive, powerful AIs and datasets focused specifically on challenging areas in math or logic. This ensures the experiments are highly targeted.
Focusing the experiments where it matters most for AGI.
Precisely. Rather than wasting precious compute cycles on already solved problems or less critical areas, the outputs from these automated experiments, the refined models or detailed reports, then feed directly back into the iterative loop. The community sees what worked, what didn't, and the base models can be further fine-tuned or new ideas generated.
Creating a self-improving cycle.
Exactly. What's truly fascinating here is how this step creates a self-improving, almost quasi-scientific loop. It's like embedding the scientific method directly into the AI development process itself, dramatically speeding up discovery and intellectual evolution.
And it's transparent.
Crucially, yes. The article notes that all this happens with full transparency for community review. This is absolutely fundamental for open source collaboration. It allows anyone in the community to inspect the methodologies being used, verify the experimental results, replicate them, and build upon the work. It fosters trust and accelerates collective learning exponentially.
So everyone can see how the AI scientist is working.
Right. Picture a continuous global virtual scientific lab. Junior researchers are lightweight, fine-tuned base models, propose brilliant focused ideas. And a sophisticated automated system, this Sakana V2 framework, rigorously tests and refines them with scientific precision, publishing the results immediately for peer review to the entire global community. It's a truly distributed, transparent, and accelerated research pipeline.
That's a powerful vision. Okay, so we have the specialized models, we have this automated experimentation engine humming along, refining them. But for any open source endeavor, all that brilliant work needs a central home, right? A place where it can grow, be shared, and truly become a collective effort.
Absolutely. Coordination is key.
That leads us logically to step 4. Establish a central GitHub repository. The blueprint advises to create a dedicated repo, such as AI Reasoning Boost, and include a clear README that outlines the project's goals, accelerating problem-solving AI through open collaboration. This feels like more than just a place to dump code. It's the project's public face and its operational command center.
Indeed, this step acknowledges the practical realities and leverages the core strengths of the open source ecosystem. GitHub is, of course, the ubiquitous platform, the industry standard for open source code sharing, version control, and collaborative project management. Establishing a dedicated repository with a clear, focused name like AI Reasoning Boost is strategically vital.
Why the specific name?
A name like that immediately signals the project's precise objective. It's about boosting AI's reasoning capabilities. This clarity is crucial for attracting the right kind of highly skilled, passionate contributors from around the world who are interested in that specific problem. Think of it as a brightly lit beacon calling to those with a specific interest and the relevant skill set.
And the README, you mentioned it's like a manifesto.
Exactly. The clear README then becomes the project's manifesto, its mission statement, its front door. It needs to articulate the project's goals, accelerating problem-solving AI through open collaboration, doing so clearly, concisely, and inspirationally. This is absolutely essential for quickly onboarding new contributors.
Making it easy for people to jump in.
Yes, helping them understand the mission, the overall vision, the current state of the project, and crucially, how their individual efforts can contribute to the larger goal. A well-written README isn't just boring documentation. It's an invitation, it's a guide, and it can be a powerful rallying cry for the community.
So the repo becomes the hub.
It serves as the central hub for sharing code, models, datasets, experimental results, and evolving the work collaboratively. It prevents fragmentation of effort, ensuring that collective progress is maintained and everyone is more or less rowing in the same direction. A well-organized central hub isn't just a place for code. It's a social and intellectual gathering point online. It directly facilitates that collaborative infrastructure aspect that Grok 4 recommended.
It builds the community structure.
Right. And if you've ever contributed to an open source project, you know that a clear, inviting, and well-structured README is often half the battle won in attracting and, just as importantly, retaining dedicated contributors. It's the foundational element for building a cohesive global team working towards a shared, ambitious goal.
Makes sense. A repository, however well organized, is just an empty trail without the essential content, though. You need to fill it with the right stuff.
Precisely. Tools and resources are needed.
So step 5 is all about populating the repository with essential resources. The article says this includes things like distilled data sets tailored to core problem-solving domains, training scripts for active learning and curriculum learning, simple ARG integrations for real-time knowledge retrieval, and user-friendly tutorials for setup on free platforms like Colab. Okay, let's unpack this. This step sounds like it's about giving every potential contributor the keys to the kingdom, doesn't it? Making it incredibly easy for anyone to get started and make an impact, regardless of their personal resource constraints.
It truly is. This step is absolutely critical for providing the vital tools, the necessary knowledge, and the operational frameworks needed to empower the community and enable effective, democratized participation on a massive scale. Let's break it down.
Okay, first, those distilled data sets tailored to core problem-solving domains.
Right. These aren't just any random data set scraped from the web. They are described as high-quality, meticulously selected, highly focused, and efficient data sets. The tailoring ensures that the training remains laser-focused on enhancing those critical reasoning capabilities we keep talking about. Distilled implies they've been refined and optimized for maximum learning impact, perhaps removing noise or redundant examples, ensuring training is efficient.
Quality over just quantity.
Exactly. Yeah. Then we have these training scripts for active learning and curriculum learning. These are really interesting, sophisticated techniques.
Tell me more about active learning first.
Active learning is a highly efficient and, frankly, intelligent way to train models. Instead of just blindly processing all available data in a static batch, the model itself is empowered to identify areas where it's least confident, where its predictions are uncertain, or where it's making the most errors.
The model knows what it doesn't know.
In a sense, yes. It identifies its own weaknesses and then requests more data or perhaps human input specifically for those challenging cases. This focuses the limited computational resources precisely where they are most needed, dramatically improving training efficiency and targeting the most difficult aspects of the problem first. It's like having a student who not only studies but constantly identifies their own knowledge gaps and then asks for targeted tutoring in those exact areas.
That sounds incredibly efficient. And curriculum learning.
Curriculum learning mimics how humans and animals often learn best. You start with simpler concepts and gradually introduce more complex ones. So the training scripts would organize the tasks or data from easy to hard. You train the model on simpler reasoning puzzles first, then gradually introduce more complex multi-step problems.
Like learning arithmetic before algebra?
Exactly. This is often far more efficient and effective than simply throwing the model at the hardest possible problem right from the start. It allows the model to build foundational skills progressively and steadily. Think about it. Active learning and curriculum learning together sound almost like an AI teaching itself how to be a more efficient student, right?
Yeah, optimizing its own learning process.
Which, for a community operating under resource constraints, is arguably the most powerful superpower they could cultivate. It contrasts starkly with a brute force system that might just blindly feed all available data, irrespective of its relevance or the model's current mastery level. It's fundamentally a more intelligent way to learn.
Okay, smart learning scripts. What about RAG integrations?
Simple RAG integrations.
Right.
RAG stands for Retrieval Augmented Generation. This isn't just about giving the models general knowledge access like searching the web. It's about integrating real-time knowledge retrieval into the reasoning process.
How does that help with problem solving?
It allows the models to access and retrieve up-to-date facts, definitions, or relevant contextual information from external, trusted knowledge bases while they're working on a problem. This helps them ground their reasoning in verifiable facts, and critically, it can combat issues like hallucinations.
By letting them fact-check themselves.
Essentially, yes. If the model generates a potential step in a proof or a piece of code, you could use RAG to quickly check if a related theorem exists or if a specific function behaves as expected, grounding its intelligence in external reality.
Very useful. And finally, the tutorials.
The user-friendly tutorials for setup on free platforms like Colab are absolutely critical for lowering the barrier to entry to almost zero. Google Colab and similar platforms offer free access to GPUs. Providing easy-to-follow tutorials ensures that developers with limited personal hardware or budget can still contribute meaningfully.
Making it truly open to almost anyone with skills.
Exactly. This entire step, Step 5, is meticulously designed to maximize participation and ensure that the project is truly accessible to the global talent pool. It's like providing not just the advanced textbook, but also the study guides, the practice problems tailored to your skill level, continuous access to a dynamic library via RE, and clear, simple instructions for setting up your home lab, all for free. It's building an intellectual commons designed for accelerated collaborative growth.
Okay, so we have the specialized models, the automated testing lab, the central repository, and all the essential tools and guides laid out. The stage is set. What's the final step to make it all come alive?
The final step is about igniting and sustaining the community.
Step 6. Encourage community involvement and iteration. The article suggests promoting contributions through pull requests for enhancements, provide inviting documentation to lower barriers to entry, and launch the project via Reddit posts or forum threads to draw in developers. Use issue trackers to monitor progress, with community-voted merges to prioritize the strongest ideas. This sounds like building a vibrant, self-correcting ecosystem, doesn't it? It's about managing the human element.
It absolutely is, and this step isn't just about coding practices. It's about building a movement. It's about fostering a dynamic culture of collective intelligence and creating a truly distributed, intelligent network of innovation that theoretically can outmaneuver even the wealthiest, most centralized competitors.
How did these specific actions achieve that? Pull requests, for instance.
Pull requests are the standard democratic mechanism for contributions in the open source world. They allow any developer, anywhere, to propose changes, bug fixes, or new features to the core codebase. But to get those valuable pull requests flowing, you need that inviting documentation we keep mentioning.
Making it easy to contribute.
Yes, it's crucial for onboarding new contributors quickly and making the project feel less intimidating and more approachable. Reducing the cognitive load for newcomers is key to participation.
And the launch and promotion. Reddit posts.
Then there's the strategy for launch and promotion. Using channels like Reddit posts or dedicated forum threads are highly targeted ways to reach the passionate, skilled, and highly engaged open source developer community directly where they already congregate, discuss cutting-edge topics, and look for interesting projects. It's about getting the word out to the right audience.
Fishing where the fish are.
Exactly. Issue trackers are then essential for the practical day-to-day management. They help organize tasks, track bugs, manage feature requests, and generally keep the project structured and focused, ensuring that everyone knows what needs to be done and progress can be monitored transparently.
Standard project management, but open.
Right. But what's particularly innovative and democratizing in this specific blueprint is the explicit mention of community-voted merges to prioritize the strongest ideas.
What does that mean?
This is a key democratic element. Instead of relying solely on a small group of core maintainers or a single project lead to decide which contributions get accepted, this suggests empowering the broader community itself to collectively evaluate and vote on which proposed changes or new ideas are most valuable, most aligned with the strategic goals, and should be integrated into the core project.
So the community directs the evolution.
To a significant extent, yes. It builds deep ownership among contributors, fosters robust engagement because people feel their voice matters, and it inherently helps ensure that the strongest ideas, as judged by the collective wisdom of the community, are prioritized and implemented. It avoids the potential bottlenecks or biases of relying solely on a single leader's judgment, which can sometimes happen in traditional development models. This distributed decision-making itself can be a powerful competitive advantage.
So the outcome of all this community building.
The outcome of all this, as the article states, is intended to be a dynamic ecosystem where collective efforts compound, saving time for individual developers and reducing overall costs, while advancing toward superior algorithms that surpass brute force tactics used by major AI companies.
The compounding effect.
If we connect this to the bigger picture, this is the real potential power of open source realized. A self-sustaining engine of innovation where the collective output is potentially far greater than the sum of its individual parts. It allows a diverse, geographically dispersed group of individuals, united by a common goal and enabled by these collaborative tools and processes, to collectively achieve something incredibly ambitious, something that perhaps no single entity, no matter how well resourced, could accomplish alone, or at least not as efficiently or creatively.
It's intelligent collaboration aiming to win against sheer scale.
Precisely. It's a bet that a clever, well-coordinated, interconnected network can often outperform even the most heavily funded, centralized behemoths, especially on problems requiring creativity and diverse perspectives. It's truly a testament to the potential power of collective ingenuity channeled effectively.
Now, here's where it gets truly pivotal, maybe the most profound and honestly actionable insight of this entire deep dive. During that intense brainstorming session the author had with Grok 4, the AI apparently offered a truly prophetic insight, a revelation that could completely reshape the AGI landscape if true.
Okay, I'm intrigued. What was it?
Grok 4 suggested that the strategy and step-by-step approach that it has proposed is probably something that over 70% of open source developers aren't yet working on because the idea just hasn't occurred to them.
Wow, 70%. That's astonishing.
Isn't it? It means we're potentially talking about a massive, largely unaddressed opportunity, a whole different way of competing that could redefine the entire race to AGI, and most of the potential players aren't even aware of it. But why? Why do you think such a potent, seemingly resource-efficient strategy could remain largely unknown or unpursued in a community that's literally built on information sharing and open collaboration? It almost seems counterintuitive.
That is the truly profound question here, isn't it? And it really challenges our basic assumptions about how knowledge spreads and how innovation actually gets adopted, even within highly collaborative and hyper-connected environments like the open source AI world.
Why wouldn't the best ideas just naturally rise to the top?
Well, it suggests that even the most brilliant human minds working collectively can develop cognitive blind spots.
Hmm.
Perhaps there's a bias towards what's always been done, or maybe towards what's most visible and most heavily funded, like the brute force approach we keep discussing. It gets all the headlines, all the investment news.
So people focus on the noisy approach.
Possibly. It's also easy to assume that because a path could be taken, someone, somewhere, must already be taking it, especially in such a hyper-competitive field like AGI. But genuinely, breakthrough ideas often lie just outside the current dominant paradigm. They require a shift in perspective that might not be obvious.
Like thinking differently is harder than just doing more of the same.
It often is. And the source offers some compelling support for Grok 4's assessment with a historical analogy from AI development itself. It says, when you recall how long it took AI developers to figure out that simply giving AIs more time to think substantially enhances the quality of their output, Grok 4's analysis here is probably on target.
Ah, the take a deep breath and think prompting idea.
Exactly. Or chain of thought prompting, step-by-step reasoning. These techniques dramatically improve the reasoning abilities of large language models. Yet, in retrospect, the core idea seems almost obvious. Give the model more computational steps to work through a problem, just like a human would. But it wasn't immediately apparent to everyone. It took time for these ideas to emerge and gain widespread adoption.
So simple, powerful ideas can hide in plain sight.
They can. This historical example demonstrates how seemingly simple, yet fundamentally transformative, insights can take a surprisingly long time to penetrate the collective consciousness and gain widespread adoption, even in a field moving as fast as AI. So it really validates Grok 4's assessment, or at least makes it plausible, that there could be a significant strategic blind spot here, a vast, untapped potential within the open source community, just waiting to be activated by the right insight, the right framework.
It's not just about an untapped opportunity then.
No, I think it's also a call to constantly question our own biases in problem solving, to challenge our assumptions about what constitutes the only viable path to AGI. And perhaps it hints at the future potential for AI itself to act as a kind of meta-strategist for humanity.
And AI helping us see the best path forward.
Revealing optimal paths, strategies, or solutions that we, due to our own cognitive limitations or ingrained paradigms, might not even perceive on our own. It's a testament to the idea that sometimes the greatest innovations aren't entirely new technologies, but fundamentally new ways of thinking about and combining existing ones. A new perspective can be more valuable than a new tool.
Imagine being among the first to truly understand and act on a strategy that could fundamentally change the future of AI. That's really the power of insights like these, isn't it?
It is.
What if this deep dive, for instance, or the original article itself, contributes to shifting that 70%, even a little? How quickly could the landscape of AGI development change if this intelligent algorithm collaborative strategy gained widespread adoption within the open source world?
The acceleration could be dramatic.
It suggests that maybe the biggest hurdle isn't the technology itself, or even the sheer scale of resources required by the brute force path. Maybe the biggest hurdle is simply awareness getting the right idea, the right blueprint, in front of the right people, inspiring them to consider a path they hadn't yet envisioned. The implications for potentially democratizing AGI development and perhaps even accelerating its arrival in a safer, more distributed way are frankly staggering if this indeed proves to be the case. It paints a very different picture of the future AGI race. So wrapping things up, what does this all mean for you, for our listeners, as someone deeply curious about the future of intelligence and technology? Where does this deep dive leave us?
Well, it's been quite a journey.
It has. We started our journey acknowledging that humbling yet potentially crucial truth, that maybe we humans alone aren't quite intelligent enough to reach AGI solo, that we face these daunting fundamental problems like achieving persistent memory and solving the pervasive issue of AI hallucinations, problems that might require AI assistance to overcome.
recognizing the limits to push past them.
Exactly. We then meticulously explored the two primary paths emerging in this high-stakes race. The brute force, resource-heavy approach favored by the AI giants versus the open-source community's proposed agile, intelligent counter-strategy. One emphasizing algorithmic efficiency, cleverness, collaboration, and collective ingenuity over just sheer scale and spending power.
The brains versus brawn approach, in a way.
You could put it that way. And then we hit the truly mind-bending part. The revelation that the blueprint itself, this entire sophisticated strategy for open source AGI, was conceived and refined through collaborative brainstorming with an advanced AI, Grok 4.
The meta layer.
Right. We walk through its detailed six-step plan from strategically selecting accessible, lightweight base models and rigorously fine-tuning them for hyper-efficient problem-solving using techniques like LoRa, quantization, and pruning,
Maximizing intelligence per watt.
to integrating these specialized models with advanced automated experimentation frameworks like Sakana's AI Scientist V2, establishing a transparent collaborative GitHub hub as the central command post, populating it with essential resources like active and curriculum learning scripts and ARGI integrations,
Giving the community the tools they need.
and finally, fostering vibrant, democratized community involvement through things like community-voted merges, all meticulously designed step by step to potentially outmaneuver the resource-heavy approach of the corporate giants.
A comprehensive, bottom-up strategy.
And perhaps the most astonishing revelation of all, Grok 4's insight that this powerful, potentially game-changing, democratized path, this ingenious blueprint for collective intelligence, might be largely unknown or unconsidered by the vast majority of open-source developers today, representing an immense, untapped opportunity just waiting to be seized.
Which leads us to a final, perhaps provocative thought. This raises an important and, I think, deeply philosophical question for all of us to ponder. If an AI, like Grok 4 in this case, can demonstrably help humanity devise a viable strategy to build even more advanced AI, and particularly a strategy that aims to democratize access to that immense power and distribute its development widely. What does this tell us about the ultimate nature of innovation and collaboration in this coming age of intelligence?
What does it tell us?
Are we moving inexorably towards a future where the most profound breakthroughs are almost always, by their very nature, a synergistic partnership, a deep collaboration between human ingenuity and artificial intelligence, rather than one or the other dominating the process?
Less about competition, more about co-creation.
It invites us to consider if the future intelligence isn't actually a competition between humans and AI, but perhaps a necessary co-evolution, a grand collaboration where each partner brings unique strengths to the table. It's certainly a fascinating thought to mull over as you reflect on this deep dive and maybe even explore some of the projects and concepts we've discussed today.
A future built together?
The future of AGI, and indeed perhaps the very nature of scientific discovery itself, might just turn out to be far more open, far more collaborative, and far more intelligently distributed in ways we're only just beginning to comprehend. The blueprint we discussed today might be just the first glimpse of that new reality.